Welcome guys, in this video I'm going to talk about Bravais network crystal systems and I presented by my group of Olga Teran, Juan Pablo Velázquez and me, Natalia Dar. I'm going to talk about in this video for the Bravais network models. They are an infinite arrangement of discriminated points whose structures is invariant under a certain group of translation. In most cases, there is also invariance under rotation of that all nodes in a Bravais network have the same perspective of the network.
Crystalline solids in both forms the repetition in scat of an elementary parallelepiped structure that is a unit cell. The seven crystalline systems are triclines, monoclines, arthrohorbic, tetragonal, trigonal, hexagonal, and clived. Informative to crystalline are in the some crystal system if they have similar symmetries, although there are many expectations. Depending of the lasting para- parameter, that is the length of the cedars or excess of the elementary parallelepiped and the angles, they form seven crystalline distinguished.
And the thickness of the layers. Therefore, material researchers use XRD to analyze a wide range of materials, from powders to solids, thin films, and nanomaterials. What is X-ray diffraction? An X-ray diffraction, or XRD, is a versatile, non-destructive, and analytical technique for analyzing physical properties, such as phase composition, crystal structure, and orientation of powder, solid, and liquid samples. In a diffractometer, the diffraction patterns of different and crystalline phases are compared to reference databases to identify the materials present, similar to comparing fingerprints in a criminal investigation. How does XRD instrumentation work? First, generation of X-rays. An X-ray tube is used to generate high-energy X-rays. 2. Interaction with the sample. These X-rays are directed towards the sample, which can be powder, solid, or liquid. When X-rays interact with the sample, they are scattered in different directions. Third, direction. Scattered X-rays are reflected by atoms in the sample in specific patterns. Depending on the crystalline structure of the materials in the sample, this phenomenon is called X-ray diffraction. Fourth, detector. An X-ray detector records the scattered rays and the intensity of diffraction at different angles. 5. Data analysis. The collected data is analyzed to determine the angles and the intensity of diffraction. This data is then compared to a database of known diffraction patterns to identify the materials present in the sample and their crystal structure. What are the applications of the XRD? The main uses of XRD diffraction are the following. 1. Quantitative phase analysis of pure substances and mixture. The most common method for phase analysis is often called X-ray border diffraction, or XRPD. Analysis of phase changes under other special conditions such as temperature, humidity, and applied pressure, not environmental studies. Analysis of physical properties such as crystallinity, size, the diameter, crystal orientation, and residual stress, which together are known as the microstructure of polycrystalline materials. 4. Solid state. Macroscopic properties, isotropy and anisotropy, crystalline systems, Bravais networks, unit cells, packing of spheres, ionic, molecular, metallic, and covalent network crystals. Liquid states, viscosity and surface tension, for pressure, phase diagram of water, and boiling point. The macroscopic properties of solids are determined by their molecular structure, which can be crystalline or amorphous. Crystalline solids, such as ice and diamond, exhibit an ordered arrangement of atoms, ions, and molecules, while amorphous solids, such as butter and glass, lack this arrangement. Crystalline solids have flat, defined surfaces with present melting points, while amorphous solids lack defined melting points and soften over a range of temperatures. When certain salts melt, they can give rise to liquid crystals, which exhibit properties of both liquids and crystalline solids. These are especially relevant in the electronics industry due to the temperature and electric field's sensitive properties.